Hello all, and thank you for listening to Mr. Laxton's video on these Chapter 5, Section 5.3 notes. So in the second part of Chapter 5, like we broke it into Part 1 and Part 2, is Part 1 is 5.1 through 5.2. 5.3 through 5.6 is still on the quadratics. It's some different ways of solving quadratics. We've solved them by factoring in 5.2, but now we're going to look at, especially in this section, by solving by taking square roots. And then we look at some complex numbers, and then solving by completing the square, and then solving by the quadratic formula is going to wrap us up in Chapter 5. So to start us off here in 5.3, my essential question is, how do I solve quadratics by taking square roots? So we're going to look at taking square roots today. And these first couple stars that we have here are going to be very important. The square root of a positive number always gives you two answers. Okay, and that's going to be key today is when we look, is that square roots always have a plus and a minus. So if I look at the square root of 4, the square root of 4 is you look at what thing multiplies by itself twice to give you 4, right? So I know that 2 times 2 is equal to 4, but I also know that negative 2 times negative 2 gives me positive 4. So the square root of 4 is not just 2, it is plus or minus 2. And that's what we're going to look at today. That's going to be important today. All right, just a couple of vocab words as we get in here. A radical sign is literally just that, radical. Here, if it doesn't have anything above it, like right here, it is a 2. We're going to look at cube roots, we're going to look at fourth roots and different things like that coming in the next couple chapters. But just here, just square roots is what we're looking at. All right, so the radicand is actually the number or the expression that is underneath that radical. So say like we have the square root of 16, 16 is the radicand. All right, the radical is kind of this whole thing, and that is any expression involving a square root. All right, so just a couple vocab words there, nothing too crazy. Perfect squares, these are going to be key today because we're going to look into simplifying square roots, and you're always going to have to give your answer in simplest form. So just like we have fractions, we don't write our simplest fraction, we don't give an answer of 6 over 4, we write that as 3 over 2. All right, so that's the simplest form of a fraction. There's simplest forms of radicals as well. All right, so we're going to look into simplifying these radicals, and what we need to look at is my perfect squares. All right, so you guys have seen these. You guys have done these a lot. 1 squared is obviously 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. Maybe I'll just go a couple more here. It might come in here. 7 squared is 49, and then 8 squared is 64. All right, 9 squared 81, 10 squared is 100. All right, but these top ones up here are going to be the ones that we're going to look at today to kind of factor out of these radicals, and we're going to look at that in a couple examples here. All right, so the first one is the product property. That's going to help us simplify square roots. So we notice here that the square root of 36, and this is kind of a bad example because you could look at the square root of 36 and say, hey, I know that's already 6. But we break 36 into 9 times 4 because 9 times 4 is 36. All right, and then you can break it up into its two different square roots. So the square root of 9 times the square root of 4. And then I know the square root of 9 is 3. The square root of 4 is 2. So 3 times 2 obviously gives me that answer of 6. All right, so this is going to be our process of simplifying these radicals. It's going to be very important. So the square root of 24, I have to look which one of these perfect squares up here go into 24. 1 doesn't really count. That one's kind of a special one. We can factor 1 out of anything, so that's not a real big deal. But I want to try to take the biggest one. So I look at this, I can take 4 out of there. So I'm just going to kind of rewrite it over here. I kind of like this to work. This is like a factor tree. So the square root of 24, I can break out the square root of 4 out of there. But how many times does the square root of 4 go into 24? It goes into there the square root of 6 times, because 4 times 6 gives me 24. And the reason why I do that, I break it into perfect squares, is because now I know what the square root of 4 is. I know that the square root of 4 is 2, but it's not just 2, it's plus or minus 2, and then we still have the square root of 6. So this is the square root of 4 in square root of 24, excuse me, in simplest form. Okay, again here we have the quotient property. It's really just the same deal here. The square root of 9 over 4, you can break it into the square root of 9 over the square root of 4, break those up into 3 and 2. All right, awesome. So this next example we can break up into the square root of 32 on the top and the square root of 4 on the bottom. The square root of 32, as I look at that on the top, I know that the square root of 32 can break into, I look at these perfect squares that go into it, I know that 16 goes into 32. So I'm going to break that into the square root of 16 times the square root of 2 all over, and I know the square root of 4 is 2. And I'm just going to kind of leave the plus or minus. I'm going to put that out in the front of my answer at the end. So now I know square root of 16, that is 4 square roots of 2 over 2. And then I can see here that, hey, 4 over 2, that simplifies to 2 square roots of 2. And I'm going to put the plus or the minus in there at the end. All right, so 2 square roots of 2 is what that all simplifies down into. So you got to look at, hey, what are those perfect squares that actually fit into there? Okay, so that example was pretty nice because the square root of 4 was on the bottom, and the square root of 4 turned into 2, right? But sometimes we end up with square roots on the bottom that aren't very nice. And the thing that we like to know is that we can't leave radicals in the bottom. So we can't leave these square roots in the bottom. So as you see here, this first example has a square root of 2 on the bottom. So what we call this is rationalizing the denominator. Okay, so I want to rationalize the denominator. We can't leave the square root of 2 as our answer on the bottom. Like the square root of 2 is some decimal. We don't like to leave decimals in the bottom of fractions and things like that. So the way that we rationalize this and the way that we write our answers, we multiply actually by the square root that's on the bottom. And if I do that to the bottom, I have to make sure I do it to the top, right? I can't just do one thing on the bottom and not to the top. I got to make it a legal move. So now here on the top, I have 3 times the square root of 2 over, and let's look at this. The square root of 2 times the square root of 2 is the square root of 4. And the reason why we do that is because now what is the square root of 4 on the bottom? Well, I should know that. It is 2. All right. So 3 square roots of 2 over 2. All right. Awesome. Great. All right. Now for the next one here, this one's going to be the square root of 16, like we talked about on the top, over the square root of 3. I notice here, hey, the square root of 3 can't just stay on the bottom. It can't simplify into anything. So I have to multiply this guy by the square root of 3. All right, awesome. I am going to not combine the 16 and the 3 because I know that the square root of 16 is 4. So I have 4 square roots of 3 over the square root of 9. 3 times 3 is 9. And then now I know that, hey, the square root of 9 on the bottom is 3, so I have 4 square roots of 3 over 3 is my final answer for that one. All right, so rationalizing that denominator, always multiply the bottom. Oh, I don't know what happened there. That is weird. Always multiply that bottom by the square root that's actually on the bottom, and then it turns into a nice square root. All right, but whatever you do to the bottom, you got to do to the top. All right, perfect. Let's keep on rolling here. The last part of these notes is solving quadratic equations by taking square roots. And this, I'm hoping, shouldn't be too bad. There's kind of some trickier examples that you can get to in these, but these examples aren't too bad. It's really, you need to isolate the squared term, and then we're going to take the square root of both sides. All right, that's the gist here. So I want to isolate this squared term in this guy right here. So I look at that, hey, just like we've always solved equations, I got to add the 2 over. So I have 2x squared is equal to 18. And then as I look onto here, I have to divide by 2 to get that square root. So now I have x squared equals 9. And then now here's really the only new part of this section, I guess, is that we have to take the square root of both sides. So this square root cancels out this square, and then I have to take the square root of that side as well. So this guy over here on the left is just x, and then, hey, I have the square root of 9. I know the square root of 9 is plus or minus 3. That's where those two answers come in. All right. Awesome. Now here we have to solve this guy. I'm going to multiply by the reciprocal, so I'm going to multiply by 2 over 1, multiply by 2 over 1, because I want to get this squared term all by itself. And notice here that the squared term is x minus 2, and that's okay. So now I have x minus 2 squared is equal to 4. All right. Perfect. So now I have to go through, take the square root, take the square root. So now I have x minus 2, because this square root cancels out with that square, is equal to plus or minus 2. So now that I took the square root there, that's where the plus or minus comes on. So now this is kind of a little bit tricky, and this is where people get mixed up, was when I add this 2 over, you cannot just say plus or minus 4. All right, so plus or minus 4, that's no, can't do that. All right, so you can't just say 2 plus 2 is 4. Right? Here we go. I like to write it as this. I always put this 2 that I added over, put that first, so now I have 2 plus or minus 2. So now one of my answers here is x is going to be equal to 2 plus 2, which is obviously 4. That's one of my answers. And my next answer is going to be 2 minus 2. And 2 minus 2 is obviously 0. All right. So again there, please don't make that mistake. When you add that 2 over in this step, make sure that that goes in front of the plus or minus, and you actually do that 2 plus 2, and then you do 2 minus 2. Going to make a big difference here. All right. Awesome. So now the next one, as we move on, it says solve this guy. This one's actually pretty nice because the square term is all by itself. So what I can do right here is take the square root of both sides. All right. Awesome. So now I have x plus 5, because this square and the square root cancel each other out, is equal to plus or minus. And then I'm going to break this guy real quick. I'm going to break into 4 and 3. All right, because that's that perfect square is 4 that goes into there. So this is plus or minus 2 square roots of 3. All right, and now subtract that 5 to the other side. And then remember that 5 goes in the front. So now I have x equals negative 5 plus or minus 2 square roots of 3. All right, and this right here, and since we have a radical in this right here, that's okay to just leave it like that. I'm all right with you just leaving it like that. So this is just my final answer right there. It's negative 5 plus 2 square roots of 3, and it's negative 5 minus 2 square roots of 3. All right, good, awesome, great, fine, dandy. All right. Perfect. Thank you for listening to my video, and hopefully this makes a little sense, and we will look at a bunch of examples like these, and we will get working on some more ways to solve quadratics. Thanks for listening, and have a good rest of your morning, night, or evening.